Hi, hello students. So welcome to the channel. So in this video we are going to make a quick revision on real numbers chapter, right? So this is useful for IIT as well as all other competitive exams, so which are based on 10th class syllabus, right? Now before going to start the video, if you are new to this channel, so please subscribe the channel and share with your friends. So don't skip the video, watch till the end, right? So let us start the video. So in this chapter, so what are the things that we have, right? So real number is nothing but the combination of rational numbers as well as irrational numbers. So what is meant by a rational number? So every number which can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. It is nothing but called as a rational number. So rational number can be expressed either in terminating or non-terminating recurring decimal, right? So first one is terminating decimal. So what is meant by terminating decimal? So how can we identify? So if you are having any number in the form of p by q, where p and q are integers and q not equal to 0, and if the denominator, that is q, if denominator is either of the form 2 power n or 5 power m, or combination of 2 power n into 5 power m. So if you have such combinations, then we can simply say that it is a terminating decimal. So other than these prime numbers, so other than 2 and 5, if you have any other prime number in the denominator, then we say as non-terminating recurring decimal. So this non-terminating recurring decimal, we can simply remember it as NTR. Okay, so NTR means other than 2 and 5, if we have any other prime number, then clearly we can say that it is a non-terminating recurring decimal. So here it is not mandatory that 2 and 5 should be present. Okay, so other than 2 and 5, if we have any other prime number, then simply we can say it is a non-terminating recurring decimal, right? Next we are having Euclid's division lemma. So what is Euclid's division lemma? So if a and b are any two positive integers, then they can be expressed as a is equal to bq plus r, where q and r are two unique numbers. So a is equal to bq plus r, where r lies in between 0 and b, right? So using this Euclid's division lemma, so we can find out HCF. So we can find out HCF of the given numbers, right? So that is one of the applications of Euclid's division lemma. Next we are having fundamental theorem of arithmetic. So what fundamental theorem of arithmetic states? So if you are having any composite number, so that composite number can be expressed as powers of products of primes irrespective of their order, right? So using this fundamental theorem of arithmetic, so we can find out HCF and LCM of the numbers. So how to find HCF? So to find HCF, we are going to take the smallest powers of the given prime numbers. So we are going to take smallest powers of the given prime numbers, and to find LCM, we need to consider the greatest powers of the given prime numbers. So greatest powers of the given prime numbers. So here, while doing HCF and LCM, all the common factors we should write. So if you are having any common factor missing in any of the numbers, then what we need to consider is, you need to consider that power 0. So you need to consider it as power 0, right? And we are having some important results related to this. So we are having a theorem: if p is a prime number and if it divides a square, then obviously it divides a. Next we are having HCF into LCM. So if you are having two numbers and their product of two numbers is equal to their product of HCF and LCM. Next HCF is, so LCM is always divisible by HCF. So HCF always divides LCM, right? Next we are having, so 6 power n. So like this we are having some questions. So 4 power n always ends with 6 power n always ends with 5 power n always ends with. So these are nothing but the questions that we have in this chapter, right? Along with this, so we are having the concept related to logarithms, right? So what is meant by logarithm? So if a and n are any two positive real numbers, and here a should not be equal to 1, so this condition should be satisfied, then x can be expressed as log n to the base a. X is equal to log n to the base a if a power x is equal to n. If this condition is satisfied, then we can express in this form. So this is nothing but we call it as logarithmic form, so we call it as logarithmic form, right? So this should be satisfied, then only we can write x is equal to log n to the base a, right? And after this, so this particular condition, so a should not be equal to 1, should be always satisfied. And one more thing, so logarithm is only applicable for positive real numbers, so it is applicable only for positive real numbers, right? Next we are moving on to laws of logarithms. So what are laws of logarithms? So we are having certain laws. So in our chapter they are given only 3 laws. So product law, so what is product law? So when you are having product of two numbers, and if you apply logarithm to that, then you can write them as sum of individual logarithms. Next, quotient law. So quotient law means, so when you are having division of two numbers, and if you apply logarithm, then we can split them as difference of two individual logarithms. Next, power law. So power law states that, so when you are having a number as some exponent, then directly when you apply logarithm, so this power will be transposed from power as product. Okay, and there are some more rules, so which you can make it a point. So log a to the base a is equal to 1, so log 1 to any base is equal to 0. The same way, if you are having log a to the base b, then I can write it as 1 by log b to the base a. So these all are nothing but the formulas, right? So if you are having log a to the base b into log b to the base c, then I can write it as log a to the base c. So I can write it as log a to the base c, right? So this is nothing but we call it as base changing rule. So this particular thing is base changing rule. So whatever the base we want, we can obtain that particular base. Next, one more thing. So if you are having a power log n to the base a, so this value is equal to some n. So whenever you are having this base and the logarithmic base, if both are equal, then we can cancel them out, then we are going to have the value as n, right? So whenever there is no base given, then you need to assume that the given base is base 10, so which we call it as common logarithm, right? So these are nothing but the concept related to this. And whenever you want to draw the graph of a logarithm, so logarithmic graph almost looks like this. So this is for a is greater than 0, and it becomes opposite when a lies in between 0 and 1. So when a lies in between 0 and 1, the graph looks like this. When a is greater than 1, my graph looks like this, right? So these two are nothing but the things which we need to remember in this chapter. Next, moving on to the problems. Now let us see the problems. So which of the following is a non-terminating recurring decimal? So already we have discussed about NTR. So NTR means, so other than 2 and 5, if you have any other prime factor, then it satisfies this particular concept NTR, right? So if you observe the denominator, this I am expressing it as 2 power 4. So this is terminating decimal. Next, so this 5 and 625, it cancels 125 times at one time, then this gives me 5 cube. So this is also a terminating decimal. Next, this is 40, so 40 I can express as 2 cube into 5. So since we are having only 2 and 5, so it is a terminating decimal, so obviously this denominator is written as 3 cube. It doesn't have, so it is having prime factor other than 2 and 5, so clearly it is non-terminating repeating decimal. Next, moving on to the next question. So terminating decimal. So terminating decimal means clearly this is terminating decimal because we are having 2 cube in the denominator. So option A is my answer. Next, which of the following variable value is a rational number? So x square is equal to 7 means if I remove this square root, then this becomes square root of 7. So square root of 7 is irrational. Next, y square is equal to 16. 16 I can write it as 4 square. So on both sides I can cancel out square. So clearly this is my rational number, right? So x square is equal to 8, k square is equal to 10 are irrationals. Next, the HCF of two consecutive natural numbers is, so if you consider any two consecutive natural numbers, so one will be odd and the other will be even. So for even and odd numbers there is no common factor other than 1. So the only answer that is possible is 1. Next, HCF of 31, 43, 47. If you observe these three numbers, so these three numbers are prime numbers. So these three numbers are prime numbers. So if you consider all the prime numbers, then HCF possible is only 1, right? Next, moving on to next question. So 7 by 80. So you need to convert this 7 by 80 as a decimal form. So how will you do? So 7 by 80. So how can I write this as 7 by 80? 80 I can write it as 2 cube into 10. So 10 again I can write as 2 into 5. So this is 2 power 4, right? So 2 power 4. So if I want to convert this into decimal form, so this 5 I need to make it as 5 power 4. So for that what I am going to do, I am going to multiply with 5 cube and divide with 5 cube. Then clearly, so in the numerator it is 125 into 7. So when I multiply this, 7 5s 35, 7 2s 14, 17, 7 1s are 7, 8. So the numerator is 875 divided by, so how many? So 2 power 4, 5 power 4, which is nothing but I can write as 10 power 4. So 10 power 4 means after decimal point we should have 4 decimal places. So after decimal point we should have 4 decimal places. So answer is option Delhi, right? Next, identify terminating decimal. So terminating decimal. So terminating decimal means denominator should contain 2 power factors or 5 power factors. So clearly this is 2 into 3. So this is not possible. Next, 13 in 65. So 13 5 65, no? So this is 50. So 50 I can write as 5 square into 2. So clearly this is my terminating decimal. Next, 75. So 75 means here you are getting a 3 factor. 49 means you are getting a 7 factor. So whenever you are having other than 2 and 5, then it is non-terminating recurring decimal. So 5 minus root 3. So root 3 is already irrational. So when you add a rational number or irrational number to the given number, then it will be an irrational number. So what is the P by Q form of 875? So, sorry, 0.875. So 0.875 means I can write it as 875 by 10 cube. So 10 cube is nothing but 1000. So in 25 table, can I cancel it? So if I cancel it in 25 table, what I am going to get? So this is 1000, this is 875. So what I am going to get? So 25 3s are 75, or simply what we can say here, so this is 875, no? So 1000 means, so 25 4s 100, so 10, so 40. So how many 25s are less here? So for every 100 we are having 4 25s. So 8 9. So out of 40 if I remove 9, so then it is 31, right? Is it correct? So 8 plus 1 9. So 31 by 40. Okay, let us see this. So 875 divided by 1000. So when I divide with the 25, so 25 3s are, so 25 3 is 75. So 75 means, so how much is left? 7 plus 3 10. So it won't go in 25 table, no? So 875 by 1000. So this I can write as 2 cube into 5 cube. So this is 875. So in 5 table, so 5 ones are 5, so 37, 5 sevens are 35, 25, so 175. So this is 5 square. Again in 5 table, so this goes 5 times, this 5 3 is 15, 5 5 is 25 again. So this goes in 7 table. So what is the answer? 7 by 2 cube. So answer is 7 by 2 cube. Next, 16 by 125. So clearly 125 means, so 5 cube. So since the denominator is containing 2 power n or 5 power n form, so clearly it is a terminating decimal, right? Next, moving on to one more question. So irrational numbers are, so already we have said nt nr. So just remember that phrase. So irrational numbers are following nt nr, n t n r, right? Next, which of the following is irrational number? So 2 and half means 5 by 2. So it can be expressed as p by q form. So root 24. So root 24 means, so 8 3s 24 or 6 4s 24. This can be written as 2 root 6. So this can be represented as 4. This is NTR. So clearly non-terminating repeating decimal. So clearly 2 root 6 is my irrational number. So which of the following is not a terminating decimal? So not a terminating decimal means it should follow NTR. So what is NTR here? So here 5, it is a terminating decimal. Next 18, so 2 into 9. So 2 into 9, 18. So option B is my answer, because 16 I can write as 2 power 4, 40 I can write as 2 cube into 5. Right? So clearly option B is my answer. Next, the value of 36 by 2 cube into 5 cube. So 36 by 2 cube into 5 cube I can write as 10 power 3. So 10 power 3 means, so after decimal point we should have 3 decimals. After decimal point 3 decimals. So this is nothing but my answer. The union of set of rational numbers and set of irrational numbers is nothing but the name of the chapter, real numbers. Right? Which of the following will be converted into a non-terminating decimal? So non-terminating decimal means NTR. So non-terminating decimal. So here 5 is there, hence it is terminating decimal. Next, this is 12 5 60. Right? So 12 I can write as 4 3s. So 4 3s again I can write as 2 cube into 3. So 12 5s. So this is non-terminating decimal. Next, here first of all we need to cancel in 3 table. So in 3 table if I cancel, this becomes 25. So 25 I can write as 5 square. Next 20. So 2 square into 5. So clearly if you observe, all these 3, option A, C, D are following all the things. So only B is having the prime number other than 2 and 5. Hence it is non-terminating decimal. Next, which of the following is not irrational? So not irrational means nothing but rational. So clearly root 4. So root 4 I can write it as 2. So 2 is rational, because root 5, root 2 and root 7. So these all are prime numbers which are under square root. So if you are having a prime number under square root, you cannot express it as a rational number. Right? Next, moving on to the next one. So HCF of 72, 126 and 270. So 72, how can I write it as? So 72 means 9 8s are 72. So 9 8s are 72. So 3 square into 2 cube. Next, 126. So 126, how can I write it as? So 270, already we know, 3 cube into 2 into 5. Next 126. So 126, how can I write? So this goes in 3 table, 3 4s are 12, 3 2s are 6. Next in 3 table again, so 3 1s are 3, 3 4s 12. Next 7 table, so this goes 2 times. So how can I write this as 3 square into 7 into 2. See, if you observe, we don't have common factors in all the things, right? So for that what I am going to do is, since I am having 7 factor here, so I am writing 7 power 0. Next, here I am having 5, no? So I am going to write it as 5 power 0. Here also 5 power 0. Here since we don't have 7 factors, so 7 power 0. Now since I need HCF, so HCF means I need to take least powers. HCF means I need to take least powers. So among 3 square, 3 cube, 3 among 3 square, 3 square, 3 cube, least power is 3 square. Next, among 2 cube, 2 and 2. So least power is 2. Next, 7 power 0, 7 power 0, 7 power 0. It is 7 power 0 and 5 power 0. Now 3 square into 2, 18. So answer is 18. Next, number of irrational numbers between any two rational numbers. So between any two rational numbers there are infinite number of irrational numbers. Right? Next, moving on to the next question. Root 5 plus 1 into root 5 minus 1. So this is a plus b and this is a minus b form. So a plus b into a minus b, I can write it as a square minus b square. So which I can express it as 5 minus 1. So 5 minus 1 is 4. So 4 is a rational number as well as 4. Right? So from this what I can say, 1 and 4. So where 1 and 4 is, so option B will be satisfied. Next, log 0.1. So 0.01 to the base 10. So after decimal point, how many decimal places are there 2, so then I can write it as log of 10 power minus 2 to the base 10. Now using power law I can write it as minus 2 log 10 base 10. So this is nothing but minus 2. So answer is minus 2. Next, log 2018 to the base 2018. Already we know log a to the base a is equal to 1. So answer is 1. Next, logarithmic form of 8 square is equal to 64. So already we know how to write this. So by taking log on both sides, so this I can write as 2 log 8 is equal to, so already we know a power x is equal to n. So if a power x is equal to n, then I can write as log x is equal to log n to the base a. So this base is always base. So whether it is in exponential form or in logarithmic form, base is always a base. That you remember, right? So this a is base of exponential form. Here a is base of logarithmic form, right? So from this what I can say? So this 2 is equal to log 64 to the base 8. So 2 is equal to log 64 to the base 8. So option B is my answer. Next question is log 54 to the base 3 minus log 18 to the base 3. So already we know this is nothing but log a minus log b form. Log a minus log b I can write as log of a by b. So 54 by 18 to the base 3. So 18 3s are 54 no. So this is 3 times. Then what I am going to get? Log 3 to the base 3. So log 3 to the base 3 is 1. So answer is option Delhi. Next, moving on to one more question. So log x to the base 4. So log x to the base 4 is equal to minus 1. So log x to the base 4 is equal to minus 1 means, so we can write it as x is equal to 4 power minus 1. So since this is in logarithmic form, I have converted into exponential form. So x is equal to 4 power minus 1. So 4 power minus 1 I can write as 1 by 4. Next, the value of log 5 to the base 25. Log 5 to the base 25. Now this I can write it as log 5 to the base 25 I can write as 5 square. So whenever you are having power in the base, then that power will come to denominator. So this I can write as 1 by 2 into log 5 to the base 5. So log 5 to the base 5 is 1. So answer is 1 by 2. So answer is 1 by 2. Next, log of root x. So how can I write root x as? So root x I can express it as x power 1 by 2. Now from this what I can say? Using power rule I can write half to the front. So from this what I am going to get? Again I am going to get 1 by 2 only. Next, log 2 is a dash number. So log 2 means, so 2 is a prime number. So logarithm of 2 gives me irrational number, right? Next, moving on to this. So already we know these formulas. Log of xy. So this is product rule. So product rule means, so option 3 will come for this. Next, this is quotient rule. So quotient rule means you will get minus. Next, these are nothing but power rule. So power rule means, so for the value if you are having power, that will come in the numerator. For the base power you will get in the denominator. So m by n into log x to the base a. So option 1 will come. So for this obviously option 2. So where you are having 3 4 1 2, so check the option. So 3 4 1 2. So option B is my answer. Next, moving on to some more questions. So 100 by 81. So this 81. So 81 is nothing but 3 power 4 no. So clearly the denominator is does not contain 2 power n or 5 power m form, right? So clearly it is non-terminating recurring decimal. So non-terminating recurring decimal. Next, which of the following is not irrational? So not irrational means, so not irrational means rational. Not irrational means rational. So if you observe cube root of 8, so already we know 8 I can write it as 2 cube. So cube root of 2 cube. So cube and cube root gets cancelled. This I am going to get 2. So hence the answer is option A itself. Next, the LCM and HCF of two rational numbers are equal. Then the numbers must be. If LCM and HCF of two rational numbers are equal, then the numbers must be. So if LCM and HCF both are equal, then the numbers are equal. So numbers must be equal. So then only LCM and HCF will be equal. So there is no other possibility. because if you take prime numbers, so HCF will be 1, LCM will be product of their numbers, so it is not possible. So it is only possible when they are equal. If A is equal to x cube y square, B is equal to x square y cube, then what is he asking? HCF of A comma B. HCF means you need to take the least powers. So among these two, x cube and x square, what is the least power? X square, and y square y cube, y square. So HCF is x square into y square. Next, rational numbers between 2 and 3 is, so how many rational numbers you can write between 2 and 3? So we can write infinite number of rational numbers, but here there are options given, so based on that you need to answer. So 4 by 12, so 11 by 4, so 11 by 4 I can write it as 3 point something, right? Is it correct? Because 4 3s are 12, no? So it is nothing but 2 point something. Next, 7 by 4, so 7 by 4 means, so it will be 1 point something. So 13 by 4, so 13 by 4 is 3 point something. So between 2 and 3, so what is there? So it is only 11 by 4. Since option B, so it comes only if it crosses 8 in the numerator, right? So clearly option A is my answer. So how many numbers in the following list are irrational? So is asking which of these are irrational. So clearly root 8 is irrational, because you cannot write it as, so root 8 is nothing but 2 root 2, right? So it is irrational. So 22 by 7 is rational because it is in the form of P by Q, right? Root 81, so root 81 is nothing but 9, so which is rational. So 0 is rational, pi is irrational, 2 is rational. So among all these, so how many irrationals are there? So root 8 is one irrational and pi is irrational. So how many are there? Only 2. So the answer is 2. Okay, next moving on to one more question. So after how many digits will the decimal expansion come to an end? So if you observe 8 here, so 8 is nothing but 2 cube. So based on this combination of 2 cube into 5 cube, so we are going to decide, so after how many decimals will it come to an end. So it is considered by considering, so if you are having 2 power n into 5 power m, so by taking the LCM of m and n, so we are going to decide after how many decimal points. So by taking LCM of this, so we are going to decide after how many decimals they are going to come to an end. So answer is option 3. Next, LCM of 12 and 42 is 10m plus 4. So he has given, so 12, so 12 means 2 square into 3. Next, 42, so 7 6 are 42, no? 7 into 2 into 3. Now based on this, so this is 7 power 0. So what is the LCM then? So LCM is nothing but highest powers, no? So 2 square and 2, 2 square, 7 power 0 and 7 power 1, 7, 3 power 1. So what is the value? 2 square is 4. So 2 square is 4, 7 3s are 21, 21 4s 84. Now if I write this as 10m plus 4 form, so 10m is equal to 80, m is equal to 8. So the answer is m is equal to 8. So answer is option Delhi. Next, HCF of 15 and 21. So how can I write 15 as? So 15 can be written as 3 5s, 21 can be written as 7 3s. Now since it doesn't contain 7, so 7 power 0, it doesn't contain 5, so hence it is 5 power 0. Now what is the HCF? So HCF means you need to take the least powers. So least powers means 3 power 1 into 7 power 0 into 5 power 0, which is nothing but 3. So clearly 18 minus 3x is equal to 3. So transpose this 3 to the other side, minus 3x to the right hand side. So from this what I am going to get? 15 is equal to 3x. So from this x is equal to 5. So clearly x is equal to 5. If root 2 is equal to 1.4, then what is the value of 1 by 2 root 2? 1 by 2 root 2. So what I am going to do is, so 1 by 2 root 2 is given now. So I am going to multiply and divide with root 2. Then what I am going to get? So this I can express it as root 2 divided by, so root 2 into root 2 is 2, 2 2s are 4. So already we know root 2 value. So 1.4 divided by 4. 1.4 divided by 4. So this I can write it as 14 by 40. So 14 by 40 means 7 by 20. So answer is 7 by 20. Next, identify the true statement. So true statement means, so you need to take the subset of the number system. So natural number is the least number system, after that whole numbers, after that integers, after that rational numbers, after that real numbers. So based on this, so which is satisfying? So natural numbers, whole numbers, integers, rational numbers. Natural numbers, whole numbers, integers, rational. So this is not following the order. So the answer is option Bombay. Next, moving on to the next question. So 27 whole power 2 by 3. So how can I write it as? So 27 means 3 cube whole power 2 by 3. So already it is in the form of a power m whole power n. So a power m whole power n I can write as 3 power 3 into 2 by 3. So 3 gets cancelled. So what I am left with? 3 square. So 3 square is 9. Which of the following is irrational? Which of the following is irrational? So already we know root 8 is irrational number. So this I can write as 4 by 5. This I can write it as 4 by 100. So 4 by 100 is nothing but 2 by 10. So all these are rational numbers except root 8. Next, HCF of these, HCF of two numbers is 113. LCM of two numbers is 56952. If one number is 904, other number is. So already we know HCF into LCM is equal to product of the numbers. So when I substitute these values here, so 113 into 56952 is equal to 904 into B. 904 into B, right? So from this, B is equal to 113 into 56952 divided by 904. So if you observe this, so here 52 is there, here 04 is there, so we can cancel it in 4 table. So in 4 table if I cancel, so what I am going to get? So 4 2s are 8, so 1 will be left 10, so 4 2s are 8, so 4 6 are 24 here. So 4 1s are 4, 16, 4 4 16, 4 2s are 8, so 15, so 15 means 4 3s 12, 32. Again we are going to get 14238. Next, again in 2 table if I cancel 1 1 3, here in 2 table if I cancel 7 1 1 9, right? This 113 gets cancelled. So what I am going to get? 7119. So which of the following rational number can be expressed as terminating decimal? So terminating decimal means, so clearly here 625. 625 means 5 power 4. So if I furtherly cancel 1 5 with numerator, then also I am going to have 5 cube here, right? So clearly it is a terminating decimal, right? The rational number between root 2 and root 3. So between root 2 and root 3, what is the rational number we have, right? So root 2 means 1.4, root 3 means 1.7. So between 1.4 and 1.7, so clearly 3 by 2. So what is 3 by 2? 3 by 2 is nothing but 1.5. So you need to remember these values. Okay, so the answer is 3 by 2. The HCF of the least prime number and the least composite number is, so what is the least prime number? So least prime number is 2. What is the least composite number? So 1 is neither prime nor composite. Next 3 4. So 2 and 4 are the given numbers indirectly, right? So what is he asking? HCF. So HCF of 2 and 4 is 2, right? So answer is 2. So product of any 3 consecutive positive numbers is always divisible by. So product of any 3 consecutive positive numbers is always divisible by. So consider any 3 consecutive numbers. So 2 3 4. So when I multiply this, so what I am going to get? 2 3s are 6, 6 4s are 24. So 24 is divisible by. So 5 is not possible. 6. Next 10 15. So 6 is the answer, because so when you consider 3 consecutive positive numbers, so in every 3 consecutive positive numbers, so every 3 consecutive positive numbers contain one 3 multiple as well as 1, so 2 even numbers. So among these 2 even numbers, if I consider one even number, so clearly 2 3s are 6. So always do remember, So when you consider product of any three consecutive positive numbers, then it is always divisible by 6, because every three consecutive numbers contain one 3 multiple and one 2 multiple. Okay. Next, moving on to one more question. So 41 by 1250. So 1250. So how can I write 1250 as 5 cube into, so 1250 is 5 cube into 10. No? So 10 again I can write as 2 into 5. So clearly, what is the power of 5? So 5 power is 4. So after 4 decimals it will terminate, right? Next, the decimal expansion of the number 441 by 2 square into 5 cube into 7. So 441. So 441 means, so how can I express 441 as, so 21 square only, no? So 21 square is 441. So 21 square I can write it as 7 square into 3 square, right? So this is 7 gets cancelled in this. Now take the LCM of the powers. So it's not LCM, so highest power among these two. So 5 cube and, so 5 cube 2 square. So what is the highest power among these two, 2 and 3? So 3, right? So so it is not asking about number of decimal places, so it is asking, so he is asking only about terminating or non-terminating. So clearly denominator contains 2 square into 5 cube, so hence it is a terminating decimal, right? Decimal expansion of dash is non-terminating, non-repeating. So whose decimal expansion is non-terminating, non-repeating? NTNR. So NTNR means you need to remember irrational number. HCF of two co-primes. So two co-primes is always having HCF as 1. Next, so 2 power n into 5 power n ends with 5 is, so for what value of n? 2 power n into 5 power n ends with 5. So is there any value? See here, if both powers are n's, then simply it is 10 power n. So 10 power n always ends with 0. So clearly what we can say, there is no such n which makes the given number to end with 5, right? The rational number between the pair of 1 by 2 and 1, root 1 is nothing but 1 only, no? So between half and 1, so 7 by 4, that means it crosses 1 point something. So 5 by 4, it also crosses 1 point something. So 3 by 4 is 0.75. So 9.5 also crosses 1, right? So only possibility is 0.75. Remaining all the values are crossing 1. So this is crossing 2, right? Sorry, this is crossing 2. So 2 point something. So only possibility is option Bombay. Next, moving on to one more question. So what is this curve? So this curve represents y is equal to 2 power x. Is it right? So it is nothing in the form of a power x form. So a power x form means, so it is y is equal to 2 power x, a rational number that equals to 2.6 bar. So already we have discussed about this. So 2.6 bar means nothing but 2.66666. So its periodicity is 1. So since its periodicity is 1, so we need to multiply with the 10. So this gives me 26.6666, and we need to consider 6 again. So 2.66. So from this, when I do subtraction, so this becomes 9x. So 9x is equal to, so this after decimal point 6s will get cancelled. So this becomes 24. So x is equal to 24 by 9. Again in 3 table I can cancel 8 by 3. So answer is 8 by 3. Next, fundamental theorem of arithmetic is applicable to the number. So for which numbers fundamental theorem of arithmetic is applicable? It is applicable for composite numbers, right? So among these, composite number is only 4. Next, the last digit of 6 power 50. So 6 power is always ending with 6 only. So answer is 6, because 6 power 1 is 6, 6 square 36, 6 cube 216. So all these numbers ends with 6, right? So 6 power always ends with 6 and 5 power always ends with 5. So these two things you need to remember. Next, HCF of two numbers 144 and 420 is 12. Then LCM is, so it is nothing but application of LCM into HCF is equal to product of numbers. So HCF of two numbers, so already numbers are given 144 into 420 is equal to, so what is HCF? So HCF is given as 12, and you need to find out LCM. So you need to find out the LCM. Now in 12 table this goes 12 times, because 12 12s are 144. So from this LCM is equal to 420 into 12. So 42 tens are 420 plus 42 2s 84. So 4200 and 840. So when you add this, so 0405, it gives me 5040. So 3 irrational numbers lying between 2 and 3. So how can I write 2 as? So 2 I can express as root 4. The same way root 3 I can express as root 9. Now in between root 4 and root 5, sorry, root 4 and root 9. So what are the values that I can write? Root 5, root 6, root 7, root 8. Right? So what are the answers then? So root 5, root 6, root 7. Right? Next, moving on to one more question. So rational numbers lying between minus 4 by 5 and 7 by 5. So already we know, so minus 4 by 5 and 7 by 5. So what are the rational numbers which are equidistantly we can write? So minus 3 by 5, minus 2 by 5, minus 1 by 5, 0 by 5, 1 by 5, 2 by 5. So likewise we can write 6 by 5. So 3 by 5 already belongs to this group. 6 by 5 also belongs to this category. Minus 2 by 5 also belongs to this category. So from this what I can say? All the above. Next, the value of 0.00675 when divided by 0.27. When divided by 0.27. So how can I write this as 0.00675 means? So 675 divided by, so after decimal point how many zeros are there? So 10 power 5 divided by 0.27. I can write as 27 by 10 power 2. Now 10 power 5, 10 power 2, I can cancel it 10 power 3 times. So from this what I am going to get? 675 divided by 27 into 10 power 3. Now cancellation. So 7 plus 5, 12, 12 plus 6, 18. So clearly this is divisible by 3. So this is in 3 table 9 times, 3 tables. So 3 2s are 6, 3 2s are 6, 25. Next, so 5 plus 2 7, 7 plus 2 9 again. So in 3 table I can cancel it out, or directly I can cancel it in the 9 table. So in 9 table if I cancel, so 9 2s are 18. Next 4, so 29 by 10 cube. So 29 by 10 cube, right? So 9 2s 18 and 4 will be left. 9 5s are, so 9 5s are 45, right? So here this goes 25 times. So 25 by, so 10 cube I can write it as 2 cube into again 5 cube. So this 25 in 5 cube, it goes 5 times. So what I am going to get? 1 by 40. So 2 cube is 8, 8 5s are 40. So 1 by 40 means, so instead of cancelling, what we can do here? So we can so instead of cancelling, simply write it as it is. So since we are having everything in the decimal form, so make it as decimal. So 25 by 10 cube. So 10 cube means after decimal point we should have 3 decimals. So 0.025. So answer is 0.025. So which of the following is an irrational number? So irrational number means, so clearly this minus root 2 plus root 3 minus root 3 gets cancelled here. So it is rational number. So this is not possible. 2 plus root 3 whole cube. So 2 plus root 3 whole cube gives me 4 plus 3 plus 4 root 3. So clearly I am having 4 root 3, hence it is irrational number. So let us see the remaining also. So here root 2 and 1 by root 2 is there. So when you take 2ab, root 2 and 2 root 2, so root 2 and 1 by root 2 gets cancelled. So giving me a rational number. So here also a plus b into a minus b. So clearly a square minus b square. So here also I am going to get rational number 1. So only possibility is 4 root 3. So hence it is irrational number. Next, log of 0.001 to the base 10. So already we know. So after decimal point how many numbers are there? So there are 3 decimal places. So this I can write as 10 power minus 3 to the base 10. So this gives me minus 3 by using power rule. So answer is minus 3. Next, log 5 plus log x. So already this is in the form of, so product rule, right? So using product rule, so what we can say, log 5 plus log x can be written as log 5x is equal to log 60. So 5x is equal to 60 on comparison. So when 5x is equal to 60, x is equal to 12. So what is the answer? So answer is 12. Next, moving on to matching. So 3 by 8. So 3 by 8 means, so what is its expansion? So by looking at the different values, so denominator is 4, so 4 in 25, so 4 point something, so 4 6 are 24, no? So clearly this is 3. Next, 26 by 25, it is just greater than 1, so 4. So where I am getting 4 and 3? So 4 and 3 is possible here, right? So option C. So most of the problems we can do in this way, right? Next, 16. So 16 I can write as 2 power 4. So 4 will be coming here. So from this x is equal to 4. Next, log 1 to any base is 0. So y value is 0. So when I add these two, I am going to get the answer as 4. Next, 243. So 243 means 3 power 5. 3125 means 5 power 5. 5 power 5. Now from this what I can say? Log of 3 by 5 whole power 5 to the base 3 by 5. So using power rule, this becomes 5. So answer is 5. Next, moving on to one more question. So 1 by log xy to the base x. So when I bring this to numerator, then what will happen? So base will change. Now I can write it as log x to the base xy plus log y to the base xy. Since both the bases are equal, and what do you have? Plus, then you can use product rule, no? So log x plus log y. So log x plus log y I can write as log xy to the base xy. So log xy to the base xy is 1. So answer is 1. Next, moving on to one more question. So x square plus y square is equal to z square. So this is the condition given and you need to answer this. Now first of all, so whenever you want to do simplification, so bases should be same. So for that what I am going to do? I am bringing these two denominators to numerator. Then what I am going to have? So log x plus y to the base x plus log x minus y. So this is not x, this is z. So this is z plus y, this is z minus y. So log z minus y to the base x. Now if you observe, so both the bases are same and you are having plus here, right? So from this you can apply sum rule. So from this what I am going to get? Log of z plus y into z minus y. Z plus y into z minus y to the base x. So since these are in the form of a plus b into a minus b, so I can write it as log of z square minus y square to the base x. Now from this condition, so what is the value of z square minus y square? So if I transpose this y square, it becomes minus y square. So z square minus y square is x square. So from this log x square to the base x. Now using power rule, so this becomes 2. So the answer is 2. Next, the logarithmic form of root 49 is equal to 7. So first of all, write it in the form of exponential form. So 49 power 1 by 2 is equal to 7. So this is nothing but a power x is equal to n. So from this x is equal to log n to the base n. So from this what I am going to get? Half is equal to log 7 to the base 49, because base is always a base. So just remember that simple rule. So from this what is the answer? Half is equal to log 7 to the base 49. So option D will come, right? Next, moving on to the exponential form of log x root x to the base a is equal to b. So what he has given? Log root x is to the base a is equal to b. So here base will be always base. So from this what I can say? Root x is equal to a power b. Root x is equal to a power b. So option C is my answer. Next, log 2 to the base 10 is equal to 0.3010. Now what is he asking? Log 8 to the base 10. So 8 I can write it as log 2 cube, right? So 2 cube to the base 10. By using power rule, I can write it as 3 log 2 to the base 10. So already we know log 2 to the base 10 value. So 3 into log 2 to the base 10 value is 0.3010. So when I multiply with 3, so this becomes 0.9030. So clearly the answer is 0.9030. Next, moving on to one more question. Log of cos 60 to the base sin 30. So cos 60 value, sin 30 value, both are same. So log a to the base a value is 1. Next, already we have done this problem. So 1.3 bar. So 1.3 bar is nothing but equal to 3 by 4 whole power minus 1. 1.3 bar is nothing but equal to 3 by 4 whole power minus 1. So this question already we have discussed in our model paper of IIIT, right? So what is the answer then? So it gives me minus 1. Next, moving on to one more question. So log of x minus 3 to the base 2 is equal to 4. So this is the given question. So from this what I can say, x minus 3 is equal to 4 power 2 or 2 power 4, because base is always base, right? So this becomes 2 power 4. So 2 power 4 is 16. So from this x is equal to 19. So the value of x is 19. Next, moving on to the next question. Log b with the base a is equal to c. Log b to the base a is equal to c. Then what is the value of log b to the base 1 by a? So 1 by a I can write it as a power minus 1. So basing on this I can write as 1 by minus 1 to the base log a to the log b to the base a. Already we know log b to the base a is nothing but c, right? So when I replace with c, it becomes minus c. So the answer is minus c. What is the value of log 1 by 16 to the base 64? So how can I write 1 by 16 as? So 1 by 16 means 1 by 2 power 4. So 1 by 2 power 4 I can write as 2 power minus 4. Next, 64. So 64 I can write as 2 power 6. Now using the power rule I can write as minus 4 by 6. So these two powers will come, one in numerator and the other in denominator. So to the log 2 to the base 2. So from this minus 2 by 3 into log 2 to the base 2 is 1. So answer is minus 2 by 3 or minus 4 by 6. So here option minus 4 by 6 is given. So you can continue with that. Next, moving on to one more question. So log 9 by 16 to the base x. Log 9 by 16 to the base x is equal to minus 1 by 2. Now from this 9 is nothing but 3 square, 16 is nothing but 4 square. Then I can write as 3 by 4 whole square is equal to this. I can write as x power minus 1 by 2. X power minus 1 by 2. Now in the next step, so if I transpose this minus 1 by 2, so this x power minus 1 by 2 I can write as 1 by x power 1 by 2. So from this what I am going to get? 3 by 4 whole square. 3 by 4 whole square. Next step, so what I can write? So when I cross multiply, so x power 1 by 2 into 3 by 4 whole square is equal to 1. So from this x power 1 by 2 is equal to, when I transpose this, it becomes 4 square by 3 square. So which is nothing but 4 square is 16 by 3 square is 9. So since x power 1 by 2 now, so if I want x, so this root will become square. So this becomes 256 by 81. So where is 256 by 81? Option Delhi. Next, x is equal to log 2 to the base 5. Y is equal to log 3 to the base 5. Now what is the value of log 72 to the base 5? So log 72. 72 I can write as 8 9s are 72. No? So 8 can be expressed as 2 cube. 9 can be expressed as 3 square to the base 5. So using product rule, how can I write this as? Log 2 cube to the base 5 plus log 3 square to the base 5. Now from this I can write as 3 log 2 to the base 5 plus 2 log 3 to the base 5. Now already log 2 to the base 5, this I can write it as 3 times of x plus 2 times of y. So answer is 3x plus 2y. Next, moving on to one more question. So here log x to the base 100 is equal to a. So what is the question? Log x to the base 100 is equal to a. So from this x is equal to 100 power a. So 100 power a I can write it as 10 power 2a, right? So 10 power 2a is nothing but x. Now from this if you observe, so 10 power 2a minus 3 I can write it as 10 power 2a by 10 power 3. So already 10 power 2a is nothing but x. So x by 10 power 3 is 1000. So answer is x by 1000. Next, moving on to few more questions. So units place of 2 power 125. So if you observe, so 2 power 1 ends with 2, 2 power 2 ends with 4, 2 power 3 ends with 8, 2 power 4 ends with 16. So that means units place. So this is nothing but the configuration. So if my given number is of the form 4n plus 1, if my power is of the form 4n plus 1, it ends with 2. If my power ends with 4n plus 2, then so my power is of the form 4n plus 2, then it ends with 4. Next, if my power is of the form 4n plus 3, then it ends with 8. Next, if my power is of the form 4n, then it ends with 6. Now 125. So 125 can be written as 124 plus 1. So this is multiple of 4. So multiple of 4 plus 1 form. So 4n plus 1 form. So clearly it ends with 2. Next, HCF of this particular fraction. So while solving HCF and LCM of fraction, so what we need to do is, so whatever the thing that is asked, that you need to apply for the numerators and its opposite to the denominators. Now how to find this? So what I need to take? So you need to take HCF of numerators by LCM of denominators. LCM of denominators. What is LCM of 2 comma 4? 2. LCM of 3 comma 5 is 15. So answer is 2 by 15. So for suppose if LCM is asked, then you need to take LCM of numerators by HCF of denominators, right? Next, the least number that is divisible by all the numbers from 1 to 10. So if you want to get a number which is divisible by all the numbers 1 to 10, so first of all you need to take the LCM of all those 10 numbers. So LCM of those 10 numbers. So what is the LCM of 10 numbers? So 2, 3, 4, 5, 6, 7, 8, 9, 10. So for these numbers you need to take the LCM. So this is 2, this is 3, this is 2 square, this is 5, this is 2 into 3, this is 7, this is 2 cube, this is 3 square, and this is 2 into 5. So based on this, so if I take LCM, so LCM means nothing but the highest powers, no? So what is the highest power among these 2, 2 square and 2 cube? So it is 2 cube. Next 3, 3 square, so it is 3 square. Next 5, so 5 you are having only 5. Next 7, so there is no other prime number, no? So 2 cube 8, 8 9s are 72, 72 5s are. So what is 72 5s? So 72 5s are. So 5 2s are 10, so 7 5s 35, 36. So 360 into 7 again. So 7 zeros are 0, 7 6 are 42. So 4 is carried. So 7 3 is 21, 25. So 2520 is the LCM. So this is nothing but the least number which is divisible by all the 10 numbers from 1 to 10. So answer is 2520. So if you asked the greatest number, then what we should do? So for the 2520 you need to take the multiples. So based on that you need to decide the answer, right? Next, if A is equal to 16, B is equal to 9, how many are rational numbers? So among these 4 conditions, so how many are rational numbers he is asking. So 16 plus 9, 25. So square root of 25 is a rational number, right? So this is a rational number. Next, 16 into 9. So square root of A into B means square root of A into square root of B we can write now. So 16 is a perfect square, 9 is also a perfect square. So this is also a rational number. So 16 minus 9 is 7. So root 7 is not a rational number. Root A by root B, I can write as root A by root B. So since A and B are perfect squares, so this is also a rational number. So how many are there? So we got 3 rational numbers. So the greatest number of 4 digits which is exactly divisible by each of the 12, 18, 40 and 45. So for this also what we should do? So we need to take the LCM of these 4 numbers. So 12, 18, 40 and 45. So what is 12? So 12 is 2 square into 3. Next 18, 2 into 3 square. Next 40, 8 5 is 40, so 2 cube into 5. Next 45, so 45 is nothing but 3 square into 5. Now among these, so all are having only the values of 2, 3 and 5. So simply what we are going to do, So we are going to take the highest powers. So 2 square 2 cube, so 2 cube is the value. Next 3 square, so 3 square 9 into 5, so 9 5 is 45, so 45 into 8, so 8 5s are 40, so 4 is carried, 8 4s are 32, 36. So 360 multiples we need to consider here. So the highest, so greatest number is asking now, so 9720. So if you check, so you need to consider the multiples of 360. So is it divisible by 360, right? So the answer is 9720. So 9720 divided by 360, that means 972 divided by 36. Okay, so based on 36 to 72, so here 9, so here 29, so 292. So in 6 table when we are going to get to, so 6 3 is 18, 6 4 is 24, 6 5 is 30, 6 6 is 30, 6 7s are 42. So 36 sevens, if you check, you are going to get, so 7 3 is 21, so 7 6 are 42, so 3 7s 21, 25, so 7 minus 2 is 5, no, so 252. So clearly it is satisfying the condition. So answer is 9720. So for this, so whenever you are asked to find the greatest number which is exactly divisible by means, so we need to take the LCM. Okay, next moving on to the next question. So here 6 bells, so there are 6 bells, 2, so which toll at regular intervals 2 4 8 6 10 and 12 seconds. Now is asking in 30 minutes how many times do they toll together. So if you want to have the toll together, so here also you need to find out the LCM of these numbers. So what is the LCM of 2 4 8 6 and 10? So 2 is 2, 4 is 2 square, 6 is 2 into 3, 8 is 2 cube, next 10 is 2 into 5, next 12 is 2 square into 3. So based on this LCM I can write it as, so what is the highest power? 2, 2 square, 2 cube, so clearly it is 2 cube. Next 3, 3 power 1, so here 3 power 1, 3. Next 5 powers, so we are having 5, so 5 8s 40, 43 is 120, so that is nothing but 120 seconds. So for every 120 seconds they toll each other, so at a time they are going to ring, right? So 120 second means how many seconds, so how many minutes? So 120 second means 2 minutes. So for every 30 minutes, so how many times they will toll? 15 times, because for every 2 minutes they all together rings. Okay, so based on this we are going to have 15 times. Next moving on to one more question. So log of tan 45, so what is the value of tan 45? Tan 45 is 1, so log 1 value is 0. Next tan 60 is root 3, so log a to the base a is 1, so 0 plus 1 is 1. Next 8 by 27, so 8 by 27 how can I write? 2 by 3 whole cube, so 2 by 3 whole cube. Here this also 3 by 2 whole cube, so 2 by 3 whole cube, 3 by 2 whole cube. Now if you observe this, so this 3 I can bring it to front, so this I can write as 3 log of 2 by 3 to the base 2 by 3. Here this I can write it as, so 3 by 2 if I want to represent it as 2 by 3, or instead of doing all this what we can simply do, so you can apply some rule, no, sorry, product rule. So by using product rule what I am going to get, since both the bases are same, 2 by 3, so this becomes 8 by 27 into 27 by 8, so 8 8 27 27 gets cancelled one time, so log of 1 to the any base is 0, so answer is 0. Next log a plus log b is equal to log of a plus b. This I can write it as log of ab is equal to log of a plus b. On comparison what we can say, ab is equal to a plus b. Since I need the value of a, so I need to isolate a, so this a if I transpose, ab minus a is equal to b. If I take a as common, b minus 1 is equal to b. So from this a is equal to b by b minus 1. So b by b minus 1 is the answer. Right. Next, moving on to this question. So how can I do this as? So root 2 I can write it as 2 power 1 by 2. Now breaking all the square roots, so this I can write as 2 cube. So this I can write as 2 root over 2 into 2 power 1 by 2. So this root I have written 2 power 1 by 2. 2 power 1 into 2 power 1 by 2 is nothing but 2 power 3 by 2. Again this I can write as log of root over, so base is 2 cube. Here this I can write as 2 into 2 power 3 by 2 whole power 1 by 2. Again this I can write it as log of root over 2 into 2 power 3 by 4. So a power m whole power n is nothing but a power m into n. So 2 power 3 by 4, this is power 1. Again, so this I can write as log of 2 power 1 plus 3 by 4, which is nothing but 7 by 4. Right. So 2 power 7 by 4 whole power 1 by 2 to the base 2 cube. Again this I can write it as log of 2 power 7 by 16 to the base 2 cube. Now from this 7 by 16 whole by, so this is 2 power 7 by 16, here 2 power 3 by 3 will come. So this gives me 7 by 16 3s are 48. So the answer is 7 by 48. Sorry, where is the thing that has missed? So 7 by 16. Here what is the base? So since it is 8, so we will be getting 2 cube. Next 2 power 1 into 2 power 1 by 2. So this gives me 2 power 3 by 2. So 2 power 3 by 2 whole power 1 by 2 gives me 2 power 3 by 4. So 2 power 3 by 4 into 2. So 4 ones are 4 plus 3 7, 7 by 4. So 2 power 7 by 4 whole power 1 by 2. So this gives me 7 power. So 2 power 7 by, sorry, not 16, it is 8. Sorry, 7 by 8. So from this what I am going to get? 7 by 8. So 7 by 8 3s are 24. So finally what I am going to get? 7 by 24. So here a small mistake. Okay, so answer is 7 by 24. Next, log x square minus 5x plus 7 is equal to 0, then x is equal to. So how can I write this as? So x square minus 5x plus 7 is equal to 10 power 0. So 10 power 0 is equal to 1. When I transpose this, this becomes x square minus 5x plus 6 is equal to 0. So x square minus 5x plus 6. So this is nothing but a quadratic equation, right? So if you simplify this quadratic equation, you are going to get the values of x as 3, 2. Next, moving on to one more question. So before going to that, so if you observe this, here plus sign is there, here minus sign is there, here plus sign is there. So when you are having changes in the signs, so how many changes in signs are there? That many positive roots will be. Okay, since here we are having 2 changes in sign, so from plus to minus it has changed, again from minus to plus it has changed. So that's why we are having 2 positive signs. So clearly 2 positive roots will come for this question, right? Next, moving on to the next question. The next question, p by q form of 5.2 bar. So clearly, since periodicity is 1, so I am multiplying with so I am considering this value as x. So 10x is equal to 52.2222 and so on. X is equal to 5.222 and so on. So when I do subtraction, this becomes 9x is equal to 52 minus 5 is nothing but 47. So x is equal to 47 divided by 9. So clearly answer is option C. Log 0 to any base. So logarithm is defined only for positive real numbers. So clearly it does not exist. Next, 7 power log x to the base 7. So already we have one property. So when you are having base and the logarithmic base, if they are same, then directly I can consider this value as, so what he has given, log, so 7 power log x to the base 7. So when both the bases are same, then simply its value is x. So from this what I can say, x plus 2x plus 9 is equal to 0. So from this x plus 2x is 3x. So 3x is equal to minus 9, x is equal to minus 3. So the value of x is minus 3. So in the option it is given, right? For suppose if I substitute x is equal to minus 3 here. So if I substitute x is equal to minus 3 here, but logarithm is defined only for positive values, no? So here it does not satisfy, hence the value of x does not exist. Okay, we will be getting the answer, but it won't satisfy the given equation, right? If a number ends with a digit 0, then the prime factorization of that number contains the prime numbers 2 and 5. So it is possible only for the numbers 2 and 5, because 2 5s are 10. So since we have 10 there, the number ends with a digit 0. Now next question, log tan 1 degree into log tan 2 degrees into log tan 3 degrees into so on till log tan 89 degrees. So if you observe this particular sequence product, in the middle somewhere you are going to get log tan 45 degrees, no? Log of tan 45 degrees. Already we know tan 45 degrees is equal to 1. So log of 1 is 0. So if the number is multiplied wholly with 0, then overall result is 0. So the answer is 0 for this question. Next, log root 5 into root 5 into root 5. So under root 5, under root 5, under root 5, and so on infinity to the base 5. So if such a question is given, so what you are going to do? So consider root 5 into root 5 into root 5 into root 5 into so on is equal to some x. Then what will happen? So directly from the infinity, if I remove 1 root 5, so there won't be any reduction, right? So directly what I can write? So I can write it as root 5x is equal to x, right? So instead of this root 5 into root 5 into root 5 into so on infinity, I can replace this x, no? So directly I am going to get root 5x. On squaring on both sides, I will be getting 5x is equal to x square. 5x is equal to x square. So when I transpose 5x, then it gives me x square minus 5x is equal to 0. On taking x as common, I am going to get x minus 5 is equal to 0. Either x is equal to 0 or x is equal to 5. Since this is nothing but having some value, no? So root 5 into root 5 into root 5 into root 5 into so on. So under the square roots we are having some value, hence it is not equal to 0. So the only possibility is x is equal to 5. So clearly this whole value is equal to 5. So from this log 5 to the base 5. So what is the value of log 5 to the base 5? It is nothing but 1. So answer is 1. Next, moving on to one more question. So I hope this is the last question of this session. So log x square minus 3x to the base 2 is equal to 2. Now by using exponential form, so I can write it as x square minus 3x is equal to this base becomes 2 square, which is nothing but 4. So when I transpose this, this becomes x square minus 3x minus 4 is equal to 0. Now how many sign conventions are there? You see. So from plus to minus only one sign change. From minus to minus there is no sign change. So from this what we can say, it has only one positive root. That means other one is negative. Now x square minus 3x minus 4. So find the value of x here. So minus b plus or minus square root of b square 9 minus 4ac. So 4 4s are 16 by 2a. So 16 plus 9 25. So square root of 25 is 5. So 3 plus 5 8. 8 by 2 is 4. So 1 is positive root. Next 3 minus 5. So 3 minus 5 is minus 2. So minus 2 by 2 minus 1. So clearly you can observe 1 is positive and 1 is negative. So 4 comma minus 1 is the answer. So both A and C. So these all are nothing but the bits related to real numbers. Okay. So go through this video completely. Okay. Please share with your friends the same thing. So thank you for watching the video. So stay tuned for the next videos. Right. So thank you for watching. Thank you very much.